about the introduction to dynamic memory allocation. So what is memory DMA? In C programming, the memory allocation can be broadly classified into two categories. They are the static or compiled time allocation time and the dynamic or runtime allocations. The static memory allocation, which is used to declare a variable or an array. Mostly it is used to declare an array. Array is mostly in the form of integer data types. The size of the memory is fixed at compile time. This can lead to the two main problems. They are the memory wastage and the insufficient memory. The memory wastage, if we declare an array of size 100 but utilize only 10 elements, the remaining 90 blocks are wasted. Next, there comes the second one. It is the insufficient memory. That means if we suddenly need to store the 150 elements, we cannot grow or expand the array size during execution. The dynamic memory allocation is the process of allocating memory manually during the execution runtime from a specific region of memory called the heap. Unlike static memory, which is managed on the stack, DMA gives the programmer complete control over the lifetime and size of the allocated memory blocks. Note it down. Here's a key rule. Please note it down. Since heap memory is allocated manually, it does not get destroyed automatically when a function ends. The programmer must explicitly release it back to the system to avoid memory leaks. Next, here comes how should we use this. It is heavily used in the standard systems programming, data structures and production level software development for the following purposes. Dynamic arrays, which are the exact number of elements or data inputs, is unknown until the runtime. Next one, the advanced data structures, implementing linked list, trees, graphs and dynamic stacks or queues, where nodes are continuously added and removed dynamically. Next, there comes the efficient resource utilization, releasing substantial buffers or structures immediately after use to optimize system RAM overhead. To use DMA functions in C, you must include the standard library header file, which is given here. Please note it down, it is very important. Next, there comes the types of DMA. See, in DMA also we are having various types. There are 4 core built-in functions provided by the stdlib.h header file for managing dynamic memories. The first one, malloc. It is a function that stands for the memory allocation, which allocates a single continuous block of raw memory of a specified number of bytes. It contains the garbage values initially. Here's the given syntax for the above said allocation. Next, here's a simple program. We can clearly see this. Please note it down, which is very helpful for you. Next, there comes a calloc. It is a function that stands for the contiguous allocation. It allocates multiple blocks of memory of a specified size and automatically initializes all bytes to 0. And here's a simple syntax. Note it down. Also the program. These two are very helpful for you for clear understanding and for the clear usage. Next, there comes the realloc, which stands for the reallocation. It is used to dynamically alter the size of the previously allocated memory blocks, either expanding or shrinking them, without losing existing data. Here we have provided you a simple syntax and the example program, which would be very helpful for you for clear understanding. Next, here comes the last one, the free alloc. It means release memory. It deallocates or releases the block of memory back to the heap pool so that it becomes available for future reuse by the systems. Here is the syntax and the example program. Okay, that's all for today.